When you think about some of the biggest applications in the world, have you ever wondered what's making them tick under the hood? Well, today we're pulling back the curtain on one of the most powerful and popular programming languages on the planet, Java. We're going to start from absolute zero, and I promise by the end of this, you won't just get the core concepts, you'll see your very first line of code come to life. Let's do this.
Hey everyone, a huge welcome from all of us here at Interview Audit. We're so excited you're joining us on this journey.
All right, I want to start with a little riddle. What is the one thing that connects building entire worlds in Minecraft, scrolling through pretty much any app on an Android phone, and the super fast financial systems that power Wall Street? The answer to all of that is Java. It's this invisible engine running a massive part of our digital world.
So that brings us to Section 1. Why even learn Java? Well, it's pretty simple. It's the language that is truly everywhere. But what is it that makes it so special, so trusted by developers all over the world?
So what's Java's secret sauce? Well, developers love it for a few big reasons. It's object-oriented, which is just a fancy but really smart way to organize code. And it's famous for being super robust and secure. But the real game changer, especially for us just starting out, is that last one on the list, platform independent. This right here, this phrase, is the absolute soul of Java. Write once, run anywhere. Imagine this. You can write your program on, say, a Windows laptop, and that exact same code will run perfectly on a Mac or a Linux server or tons of other devices without you having to change a single thing. This was totally revolutionary, and it's a huge reason why Java is still such a powerhouse today. So how in the world does Java pull off this run anywhere magic trick? Well, the secret is all in its engine. Now, fair warning, you're about to hear a few acronyms: JVM, JRE, and JDK. They might sound a little intimidating, but I promise we're going to make them incredibly simple to understand.
At the very heart of it all is the JVM, the Java Virtual Machine. The absolute best way to think about it is as a universal translator. See, your computer doesn't naturally speak Java, so the JVM acts like a middleman, sitting between your code and the operating system, translating your instructions into a language the machine can actually understand. Every platform, Windows, Mac, Linux, has its own special JVM, and that's the key that lets your one program talk to all of that. Okay, let's zoom out just one level to the JRE, the Java Runtime Environment. If you've ever downloaded something to get a game like Minecraft running, this is probably what you installed. The JRE includes that super important JVM translator, plus a bunch of core code libraries that programs need just to function. So, for running stuff, you need the JRE. But what if you want to build your own programs? That's when you need the big one, the JDK, the Java Development Kit. This is the complete developer's toolbox. It has everything that's in the JRE, including the JVM, but it also adds all the essential tools you, the developer, need to write and compile your code. So for our journey, the JDK is what we'll be using. This table here just lays it all out perfectly. Think of it like a set of Russian nesting dolls. At the top, you have the biggest doll, the JDK. That's your full toolbox for building apps. Inside that, you find the JRE, which is just what you need for running them. And then at the very core of the JRE is the smallest doll, the JVM, the translator that makes everything possible. So the JDK contains the JRE, which contains the JVM. Simple as that. Okay, enough theory. It is time for your first victory. In the world of programming, there's this time-honored tradition for anyone learning a new language. It's a rite of passage, really. And it's simple: making the computer say hello to the world. And there it is, your entry ticket into the world of Java development. I know, it might look a little strange at first, but the single, powerful line is actually a very, very precise instruction to the computer. Let's break down exactly what it's saying. Let's just crack this thing open. System.out, all that's doing is telling Java, hey, I want to target the main output, your screen. The next part, .println, that's the command, or what we call a method. It literally just means print a line. And what are we printing? Whatever's inside the quotes. Hello world. See? Once you know the grammar, it's a perfectly logical sentence. Fantastic! You have officially made a computer speak. But to build truly smart programs, we need a way to remember and manage information. And that's where we meet the core building blocks of any program: variables and data.
So what on earth is a variable? Honestly, the best way to think about it is as a labeled box or a container that lives in the computer's memory. You give the box a name, and then you can put a piece of information inside it to use later. For instance, we could have a box named player score and put a number in it. Now, here's the thing about Java. It is very, very organized. Before you can use one of these variable boxes, you have to tell Java exactly what kind of data you plan to store inside. We call this a data type. As you can see here, for whole numbers, we use int. For numbers with decimals, we use double. For simple true or false decisions, we use Boolean. And for any kind of text, we use string. You just declare the type, give your variable a name, and assign it a value. That's it. Okay, so once you have data stored in your variables, you need tools to actually do something with it, right? That's where operators come in. These are basically the action words of programming. All those familiar symbols like plus, minus, multiply, and divide that let you perform calculations and bring your data to life. So far, we can store data and we can make our program talk to the user. But a truly great program doesn't just talk, it listens. So let's take a look at how we can make our programs interactive. Think about it. Right now, our program is basically giving a monologue. But the best applications, they have a dialogue, a conversation. They don't just talk at you, they listen and respond to what you do. So how do we open up that line of communication in Java?
The answer is a really handy built-in tool called the scanner. When you use the scanner in your code, it pretty much tells the program to just pause and wait. It listens for you, the user, to type something into the console and hit enter. And as soon as you do, the scanner grabs that text and you can immediately store it in a string variable to use however you want. This is how you start having a real conversation between your user and your program.
And just like that, you've grasped the absolute fundamentals of Java. Now, the best way to make these concepts really stick is to put them into practice. You can test out your new knowledge in a real-world scenario with our AI agent over on interviewaudit.com. Your first 2 mock interviews are completely free for new users, so it is the perfect next step to really solidify what you've learned today. We've gone from zero to understanding how Java's engine works, how to write your very first command, and even how to make your programs listen. You've taken the first and most important step. So now the only question left is this. You've learned how to make a computer say hello.